Hi, we're starting Chapter 3 today. You just finished the Chapter 2 quiz in class, and you're watching this video to introduce Chapter 3, Lesson 1. And Chapter 3 is solving linear equations. If you want to take a look right now on page 130, if you open your book, go to page 130 real quickly, you'll see the title, Solving Linear Equations. The first thing is, what does it mean to have a linear equation? All right. Now remember, a linear equation creates a straight line graph. When you think of the word linear, you can see the word, let me fix that, you can see the word line in linear. So a linear equation is an equation that when we graph it is going to produce a straight line. How can you tell by looking at an equation if it's linear? All right, this should be a quick, actually 3-second process. You can look at an equation and instantaneously know if it's linear or not. Basically, a linear equation is an equation that doesn't have any exponents in it. Okay? So here would be an example of a linear equation, like 3x plus 2 equals y. There aren't any second powers or third powers, so on in it. That it would be an example of a linear equation. All right? We are going to be working on solving equations that are linear in Chapter 3. That means the equations we will be solving won't have exponents in them. All right, so here would be an example of an equation that's not linear. 3x squared plus 5x equals y. This has a squared term in it, so it's not linear. This graph would not be a straight line. It's going to have a curve to it. We'll get to these kind of equations later on in the course, more like in Chapter 9. So we'll get to this type of stuff probably around April. Okay? So let's talk about solving, and if you go to page 134, we're going to talk about solving one-step equations. All right? And I want to say this first, and I learned this last summer. I was reading something, and I thought, wow, I never had taught this before, but it just makes a lot of sense. When you solve an equation in algebra, treat it like an onion. And you might be thinking, well, that sounds kind of crazy. Okay, treat the equation like an onion. Now, when you think about an onion, if I slice an onion in half and I draw it from the side, an onion kind of looks like this. It's going to have layers. Okay, you're going to have layers to the onion. Okay, that's kind of a cross-section of an onion. Okay. When you solve an equation, it's kind of like peeling apart an onion. You take away the outside layer first, then you take away the next layer, then you take away the next layer, and when you take away these outside 3 layers, you'd finally get to the center of the onion. Okay? If you treat an equation like this, you'll solve these right every time. Treat it like an onion. You're working from outside in. Okay? So a simple example of that, we're going to be solving one-step equations in this section. And by the way, I'm on page 134 right now through, we're going to be turning back and forth from page 134 through 138 right now. Okay? When we solve a one-step equation, if we treat it like an onion, it will be easy to solve. Let me just write a simple example of one. Let's say x plus 7 equals 4. Okay? Now here's what I mean by treat the equation like an onion. The variable is the center of the onion. So there's the center. Now the very next layer, I'm adding 7 to x. That would be the next layer of the onion. Okay? Now the left side of the equal sign is where my variable's at, so my onion, I treat it like it's on the left side of the equal sign. So right now, to get to the center of my onion, which is x, I got to peel away this layer, which is plus 7. Okay, so now this is where we get into a term that's called inverse operations, and if you look right now on page 134, you'll see the term inverse operations highlighted. Now inverse, the word inverse kind of means, in a way, like backward, okay? Operations that will undo each other. So if you think about addition, the inverse of addition is to subtract. Subtraction gets rid of addition. On the other hand, if you start with subtraction, addition gets rid of subtraction. So addition and subtraction are inverse operations. Now when you think about multiplication, the inverse of that would be division. Okay? So when I look at this equation and I think about, okay, I got to get rid of this outside layer, which is plus 7, the inverse of adding 7 would be to subtract it. So if I want to peel away this layer of the onion, what I need to do is I have to subtract 7 from the left side of the equation. But if I subtract 7 from the left side of the equation, remember equations work like, and I'm sure you've seen this before in your textbook, equations work like a balance scale. So right now on my balance scale, x plus 7 on the left is equal to 4 on the right. So if I decide to take away 7 from this side of the scale, I have to go over here and do the same thing, or else my scale becomes unbalanced. So you notice down here I'm taking away 7 from each side. So when I do that, plus 7 minus 7 cancel out, and I still have x on the left, and 4 minus 7 is negative 3 on the right, and there's my answer. Now I can check it. We should always check at the end. We should always check our answer at the end. So if I check this thing, negative 3 plus 7 equals 4. And that does work. If I put negative 3 in here and add 7, I do get 4. Okay? Now, the other thing with vocabulary, there's another term in there. It's called equivalent equations. It's highlighted. So I'm writing that down, equivalent equations. Equivalent equations, what it says, it's equations that have the same solutions. So if you're doing your work right on each step, you'll always write an equivalent equation. For example, this equation and this equation are equivalent, and here's why. If I put negative 3 into this equation, it's true. Negative 3 equals negative 3. If I go up here and I put negative 3 in this equation, negative 3 plus 7 equals 4. It's a solution to that open sentence also. So these are equivalent equations. If you're doing your work right, you will always get equivalent equations. Okay? If you get equivalent equations, you will get to the proper answer. And then one last thing before we solve a few more of these and wrap up the video. There are 4 properties that we should know when we do these, okay? We subtracted 7 from each side. There's a property that allows me to do that. That's called the subtraction property of equality. You'll see that in a blue box on page 134. Okay? The subtraction property of equality, I'm just going to say it in my own words, what this property means is as long as I subtract the same amount from each side of an equation, the equation will stay balanced, it will stay equal, and it will produce the correct result. Okay? Now there's 4 properties like that. Here I subtracted from each side, same amount, that's called the subtraction property of equality. If I had added to each side of my equation, that's called the addition property of equality, and again, you'll see that on page 134, addition property of equality. We'll use all these today on my video. I'll do an example of each just so we can see it. We also have on page 135 a multiplication property of equality. You can multiply each side of an equation by the same amount and get a correct solution. And you also have a division property of equality. Okay? When you solve one-step equations, I do want you to show work in a certain way. Okay? It's kind of like writing a sentence in English class. Your teacher's going to demand of you to capitalize the first letter in a sentence, use appropriate punctuation, spell your words right, put a period at the end. Solving equations, there's a certain etiquette to that too that we should follow. That any teacher, doesn't matter if it's Mr. Keller next year, or Mrs. Bossack, or Mrs. Bassett, Mr. Baker, and when he's teaching physics, all your teachers, I think, are going to want to see a certain method That way we don't, it's just like writing a sentence. I can't have, one person wouldn't say, well, I'm going to spell a word this way, and I don't put a period at the end because that's not how I do it. Everybody has the same etiquette to writing a sentence. Same thing with solving an equation. So when you solve a problem like number 8 on page 137, the problem says negative 3 equals 5 plus a. The first thing I'd want you to do is write the problem down. Okay? The next thing you ought to do is try to simplify each side of the equation if possible. This takes you back to section 2.5. Okay? In 2.5, we simplified. I'm just going to write that down. Okay, so let's see if we can simplify. Over here, negative 3, can't simplify that. Over here, 5 plus a, I cannot combine those together, so I can't simplify it. But I always want to try to simplify next. Okay, so now here's the next thing. Just imagine the onion. Here's the center. The next layer of the onion's right here. And remember, this is something we talked about in Chapter 2. This plus sign doesn't apply to the 5. It applies to the A. The sign in front of 5 would be a plus right now. So I got to think, how do I get rid of plus 5 to get rid of this outside layer? Well, obviously I got to subtract it. So let me just undraw my onion. I'm going to do that real quick. Okay, so I got to get rid of this plus 5 layer, so I'm going to subtract 5 from the left, and I will subtract 5 from the right. And 5 minus 5 cancel. I get a on the right, and I have negative 8 on the left. That's what my work should look like, okay? Now, by the way, I just want to put a couple more notes here. I won't make you write these notes when you solve your problems, but for your notebook, I would like you to put these in here. Think about it. What property did I use here? I used, for step 3, I did the subtraction property of equality. Just going to write that in real quick. Okay. And I just went ahead and I solved. Step 4, I guess I could put, I solved and simplified. Solved and simplified. Okay. And so anyway, I got a equals negative 8. And then here's the next thing. We don't want to forget. It's always good to check it real quick. Step 5, let's check this. Let's see if negative 8 actually works. So let's try that. 5 plus negative 8 does give me negative 3. That's correct. So remember, this equation is equivalent to this one, because if I replace a with negative 8, it's a solution here. And if I put negative 8 in for a, it's a solution here. These are equivalent equations. Okay? Here's another one. Let's solve this. Now remember, let's think about our onion. Here's the center. The center of the onion is the variable. And the next layer of the onion is right here, and it's the subtract 9. I want to work to the center of the onion, so I got to get rid of this outside layer. I got to get rid of minus 9. So remember, the inverse of subtracting was to add. So let me just erase my onion. I have to add 9 to get rid of minus 9. So I'm going to add 9 to the right. I'll add 9 to the left. Cancel. I get b on the right. I have negative 2 on the left. And maybe I should just rewrite one more time. Remember, step 1, write the equation. Always looking for that. Step 2, try to simplify. Now, in this problem, I didn't mention that. Maybe I should right now. Let me see. Can I simplify? I can't simplify negative 11. b minus 9, I can't combine those. So I tried. I can't. Step 3, I used an inverse operation. I used the addition property of equality. Okay. Step 4, I simplified and solved. And step 5, I need to check this thing. Let's check it. Okay, let's see if that actually works. Well, if I take negative 2 and replace it up here, negative 2 minus 9 does work out to negative 11. These two equations are equivalent. They ought to be equivalent if I'm doing my work right. Okay? Let's go to 20. Okay, this is on page 138. Let's do another one here. Now, if you notice this one, here's the variable. The variable is the center of my onion. Here's the next layer of the onion. Okay? You notice I have 9 times j. The 9 is being multiplied to j. So to get rid of this layer of the onion, I got to get rid of times 9 to get rid of this outside layer. I want to remove the outside layer to get to the middle. So how do I get rid of times 9? Well, remember, the inverse of multiplying is to divide. I ought to divide each side by 9. So let me just erase my onion here. Okay, I want to work into the center of the onion. My pen froze up on me for a second here. Second. Okay, so I got my pen to work again. Sorry about that. So I want to divide by 9. So let's do that. I'm dividing the right by 9 and the left by 9. 9 divided by 9 is 1. So I have 1j on the right, and negative 108 divided by 9, if I'm doing my mental math right, that's negative 12. Okay? So remember, my steps were to write the problem. I did that. Try to simplify. I did. I can't simplify either side. I tried. Can't. I used the division property of equality. Oops. Pen stopped working again. Division property of equality. Step 4, I solved and simplified. And step 5, I check it, right? Let's check it real quick. If I take negative 12 and plug it in here, 9 times negative 12 does give me 108. So this equation is equivalent to that, okay? And one last one. Let's look at 26. Okay, so I'm not going to write out my steps again. I'll just verbally say them. Here's the center of my onion, the T. And my next layer is I'm dividing by negative 7. So how do I get rid of a division of negative 7? Well, the inverse of dividing is to multiply. So to get rid of my onion, to get rid of that outside layer, I have to multiply by negative 7, which means I have to multiply the other side by negative 7 also. Okay, make sure I get a negative in there. Negative 7 divide by negative 7 times negative 7 gives me T. 7 times negative 7 is negative 49. I'm getting T equals negative 49. Let's check that. And by the way, this property, remember, that's the multiplication property of equality that I used. Let's check it. Negative 49 divided by negative 7 does give me positive 7, so these two equations are equivalent. So we want to show our work in that manner. It should look like that. I'm going to stop my video here, and if we have any questions, you can come in tomorrow and ask those.